Welcome back. There's nothing, nobody posted anything in the general channel, so there's no, I figure I might have some questions going in, but we don't. I did not have power this morning, and then it came back on. It is my hope and intent that I will be with you for the entire session today, but if I mysteriously drop out, it's not because I was offended by anything. And if that happens, then Davis or Julia, depending on what part of the notes we're at, will reluctantly jump in and finish until I am back online. One thing I wanted to show before we get started is if you're using the RStudio Server Pro, you have your login and all that. If you could log back in again, like when I do that, I get this window here. It says RStudio session. It was suspended because you weren't using it. I'm going to log into that. Resume session. And so everything is just where I left it. The one thing I did want to show how to do is in the GitHub repo. Let's see, update. I added Scratch day one, which is all the stuff that I typed in yesterday during the hands-on session. So if you want to, if you're using Git, you can just pull that down. But if you're using RStudio Server Pro, what you can do is above your console, there's a little window that says terminal. So if you click on that, you can just type git, G-I-T, pull, and that does not work. Okay, maybe I need to go into class repo. Okay, so that's the issue. So the first thing you should do is change directory into class-repo.
You're not in your project.
Yeah, I should be now. Let's see if it works now. Yes. So if you're in the class pred, it has all the GitHub information in that directory. So if you just do git pull, see all this stuff, and all it basically says is I updated and added this file for day one Scratch file. So if you go in here, you will find it down there now. Yeah, so that's a handy dandy thing that you can do. So let's see where we left off. As we just got done talking about dummy variables, and just the idea of like making numeric representations of categorical data. And then where we were at that point was we stopped up on this slide, which is about infrequent levels and categorical factors. So the thing is, if you did like a geom bar on the neighborhood variable, which has, I checked it earlier, has actually 29 levels, you'll see a bar chart that looks like this, where we have a lot of data in North Ames and College Creek. And then we have, a decreasing frequency of these, smaller and smaller neighborhoods. Green Hills, I believe, has 2 properties in it. Landmark has 1. And then it also, we did an update to this data set not too long ago, where there is a new neighborhood in Ames that we currently do not have any. It's an actual neighborhood, but we currently do not have any properties in this data set, and it's called Hayden Lake. And so what ggplot does is, if that is has 0 data points in it, even though it's a factor level, you could probably change this with some option. It doesn't get added here. But the point I wanted to make is, this is a predictor that we would probably consider using. And then we think about like data splitting and how would this work. There's a little bit of question about this yesterday in the general channel about what do you do when you get new data. This is kind of related to that, although in this particular case, we know what the neighborhoods are. So it's possible we can get a new neighborhood. But the question I had asked is like, what would happen if you do a training and test set split and landmark winds up in, let's say, the test set? So when you make dummy variables, you would have all zeros in the landmark column, which is what we call a zero variance predictor. It has it only has one unique value, in this case, 0. So the question is like, what would we do about that? Is that a big deal? Like, should we worry about that? And again, we call that a zero variance predictor because it only has one unique value, which means its variance is 0. There are a lot of models that, if you were coding them by hand, would have some numerical issues with having a column of all zeros in there. LM and GLM are pretty smart about these things, though. And what they do is when they see that, they don't crash and they don't cause, I don't even think they issue a warning, but what they will do is they'll set the coefficient for that particular column that is all the same value to be NA. So you know, again, if you were homebrewing your own method, you would have to code around this, and LM and GLM has already done that. We'll talk about trees a little bit later and how they deal with splitting on categorical factors, but this would not be an issue for those types of models, and I'll mention this later on when we talk about it. So there's a couple of different things we could do to deal with this. We could run a filter basically on the training set that says, you know, if you have any predictors that only have a single unique value, then let's not add them to the training set, which seems pretty reasonable. They have literally no value. There's literally no information in there. So, you know, you might just get rid of them if they're there. Another thing that you could do is you could do something like othering. And we'll talk about this in a second. And othering would basically be where you say, well, you know, we have some neighborhoods in here that occur very infrequently. So let's, at some threshold, let's pull them into a different factor level and just call them all other. And so then you have this like other category that you could use for the ones that may or may not be represented in your data. So that's another option we'll talk about. The thing about it is, though, is like model.matrix doesn't do any of this stuff. So it doesn't do anything about zero variance predictors. You can't set up other in there. And so it doesn't really help. And so this is a good example of why we originally created this thing called recipes. And I'd been toying around with the idea of something like this for like several years before I actually sat down and started coding it. And what you can think of like recipes is like sort of a mashup between like model.matrix and dplyr. And so as you'll see in a little bit, what a recipe is, it's a series of steps. And these steps are like model-oriented data processing operations that can be defined in a sequence and then be run to give you kind of the same type of results that model.matrix would give you, or that the formula method would give you. So let's talk about things in particular. So let's say we started off with this formula for our data, log 10 sale price, longitude and latitude. What the formula method and model.matrix actually do is they say, well, you know, sale price is your outcome, longitude and latitude are your predictors, and that we should log transform sale price. And so one thing you could do to replicate this in a recipe, what a recipe does is you start off, it has a formula method. You don't have to use the formula method. But if you want to, you can give it a, you know, sale price tilde and then this, just like we would have. It does not allow you to do any inline functions. So all the formula does here is really tell the recipe what are the predictors, what are the outcomes, and that's it. So if I typed in log 10 sale price, it would error out and say, yeah, we don't really allow for any functions in here. We want you to do as much as possible any data alterations inside the recipe. It's also pipeable. So when you start off with a recipe and a formula and the data, then you can pipe in a series of steps, and they all start with the name step underbar. So if you want to log transform sale price with base 10, what you would do is you would use step log. If you had other variables here you want to log transform, you could just like a dplyr select, type in things like sale price, comma, general living area, comma, and so on, and just add them here. And so at this point, what the recipe knows to do is it knows that sale price is the outcome, longitude and latitude are the predictors, and that sale price should be log transformed. So all it does is define those steps. And one difference between model.matrix and a recipe is model.matrix, it both defines what to do and then immediately does it. So it has this really eager execution where, you know, when you run model.matrix, it does these three steps that I listed here, but it automatically just does them. And one consequence of that is you don't have the chance to add to it. You don't have the chance to reuse that specification before it actually executes it and gives you a model matrix. And so recipes are different in the respect, as you'll see, where the initial definition of the recipe doesn't actually do anything but record, like if you were writing out a recipe, record what you should be doing as an algorithm rather than recording it and then doing it. So it's not really executed at this point. There's an issue with this recipe we will talk about in a little bit related to this. So there's nothing syntactically incorrect here, but we'll show later on why this is maybe not the best of ideas, having your outcome transformed in a recipe step. So keep that in the back of your head that we're doing something that we're going to undo a little bit later, and we'll explain why that is. So, as I mentioned, it's sort of like dplyr, where you can sort of sequentially pipe in new operations. So let's say we start with what we had before, we log the outcome, and let's say we want to try that idea of like othering the neighborhoods. And so there's something called step other, and then you can give it any factor predictors you have, and then a threshold that says basically, and this is in terms of proportion, so if 5%, so if the neighborhood has less than a 5% frequency in the total training set, we should not use that factor level, but convert that to other. So we might take, with this threshold, we might take, I don't know, 5 or 6 or 3 or 4, however many fit that threshold, factor levels in neighborhood, and redefine the factor levels to be the frequently occurring neighborhoods, and everything else gets lumped into a new factor level called other. So what this basically does is, based on data, it redefines the factor levels for neighborhood. And that way, you don't have to worry about whether landmark or green hills wind up in the training set or test set. They're all just going to get dumped into a dummy variable column called other. Now, one thing that is different about recipes and model.matrix is model.matrix will automatically make you dummy variables. And we know that, number one, there's a lot of things you might want to do with your factor predictors before you make them dummy variables. And in some cases, you don't want to make them dummy variables. So recipes do not make dummy variables until you tell them to. So you have to opt in to making dummy variables from categorical predictors. And then the way you do that is something called step dummy, which you can say, give me all the nominal, here means either factor or character, all the nominal predictors, and make them into dummy variables. So a few notable things about this is we have these functions. So if you think about dplyr, you can, if you're doing a select with dplyr, you can type out the names. You can type out things like starts with. So if we have like pool predictors for like the garage, let's say, they would start with garage underbar and something else. You can say starts with garage in this specification of the variables. So you can use your standard dplyr selectors here. Starts with, matches, and so on. But we also have a couple of others because we wanted to be able to select on data type too. So if you want to select everything that is factor or character, you could use this selector. There's also all numeric. So if you want to select all the numeric data, now it's independent of role. So in this case, if we use all underbar numeric, it would also select the outcomes. We have to be really conscious of that. And then we can also do things like minus. So we could have like a minus here. Like if we didn't want to include the outcome, we could say like all numeric, comma, minus sale price. So just like we would with dplyr. So there's things that you can select on with data type. As noted down here, you can also select on whether they're predictors or outcomes. And there's some other ways to select other things, but these are the main ones. So you can select by name using all the dplyr stuff. You can select by data type using all nominal and all numeric, for example. And then you can also select on the role, whether it's a predictor or outcome. So you have a lot of flexibility to do this. And I'll explain why we added, there's some special reasons why we added functions like this that I'll talk about in just a minute that may not be obvious at this point. So what does this recipe do? It basically says, here's my outcome, here are my predictors, log sale price, possibly convert some neighborhoods to another category, and then take all of the categorical predictors, which in this case is just neighborhood, and convert them to dummy variables. So that's what the recipe specification is. So if you take this object and print it out, it looks like this. It says, we know coming in so far we have 3 predictors and we have 1 outcome, and then it lists the operations. Now, it doesn't resolve this all nominal yet because it hasn't really done anything yet. So as you'll see in a little bit, once we sort of process this recipe, this will get substituted with any of the variables that are chosen using this type of selector. So printing this out is just to reinforce that all this has done so far is just to capture what we want to do, like the algorithm or the series of steps to enact this recipe. So here's the general process that we follow with recipes. And we will show you later on other APIs that you can use to tune models and things like that, where you don't need to worry about this part. But if you're going to use recipes for like data visualization, some other cool things you can do with it, it'd be good to know this. And so what we just showed was defining the pre-processing steps, and that's in this called a recipe. And then in some cases, you might need to estimate something. So the only estimation bit that we do in this particular recipe is we have to take the training set at this point, look at the frequencies of the neighborhoods, and estimate how many of them should be lumped into other based on this threshold. So after you define the recipe, you would run this prep function, like you're preparing a recipe, like you're cutting up vegetables and stuff like that. And so what that would do is, like, for example, if you were centering any data, at that point, it would compute the mean to know for each column that you tell it to what it should be subtracting off the center of the data. So prep is where sort of like the training data is used. It's where you estimate all the components of all the steps of the recipe that require estimation. So it really calculates a bunch of statistics from the training set. That's the important part, is everything that happens on the in the prep phase is based on the training set. And so then once we've run prep, for example, we'll know what factor levels get lumped into other, but we haven't actually applied that to any data yet. And so there's 2 different functions you could use to take a prepared recipe and actually get the data out of it based on the statistics that were calculated. And those are called bake and juice. And we'll talk about the difference between them in a little bit. But the outcome of these is you give it a recipe and the original data set, and it gives you back the process data set, which, like in this case, would have like dummy variables for neighborhood and a logged value for sale price. Let me pause because there's questions. Since tidymodels generally passes the formula from the first argument, is there a way to still autocomplete for field names within RStudio? Ooh, that's a great question. I don't think so, but let's try. So it might be kind of like ggplot, where I mentioned yesterday, like if we had a data set and we pipe that into ggplot, it can autocomplete. So let's try that with a recipe. Yeah, so I'll try it both ways, but if you start with the data being piped in, and then you want to use a formula, you can autocomplete this way, MS subclass, and so on. So as long as you pipe in the data first, yeah, it will autocomplete for you, which is good to know. I'd never tried that before. Let's try it without doing that. I don't think it'll work though. So let me just recipe.
Max, can you zoom in?
Yeah, I was about to say the same thing.
Yeah, how's that?
Looks good to me.
Looks good.
Okay. Sorry about that. So at this point, it doesn't know where the data are or anything like that. So it doesn't really have the ability to autocomplete. So if you have the data and then pipe it in, it knows how to autocomplete. You can type in whatever you want.
We actually get a little lucky that this works because we have S3 methods for recipe for both a data frame and a formula. So you can supply them in any order. So even though we normally do the formula first, technically here the data is coming in first, but that's also fine.
Yeah, it knows to look at what's first and switches them around as it needs to.
Right.
Yep. Let me wait just a second. There might be another question. So I struggle with it using too much memory when using pre-processing carrot. Is that just my issue, or is that an issue with the recipe, or are there tricks to avoid it? Yeah, so I'm trying to think, when would you run out of, memory? It depends on what you're doing in your data, right? So if you come in with like terabytes of data, that may be a struggle no matter what you do in carrot. So I'll try to, I'll answer this question, sort of divorce it from the idea of like, well, what kind of computations am I doing? I'll come back to that in a minute, but I'm trying to think about data. One thing that we have not been able to, we just haven't had time to get to it, is if you have a lot of data, like a lot of columns, if you do like recipe y tilde dot data equal, too many columns, that this does take a while to run. Just like any recipe I mentioned yesterday, like any formula, the formula method in large dimensions is not efficient. So what you can do is you could start off with a recipe and just say data equals, let's say, aims, and get the function name right. And so what it does at this point is, I'm sorry, it's X. The initial thing is aims, and it just records how many variables you have. And you might notice it says no declared roles. I won't go into this too much here, but there's a lot of documentation on tidymodels.org about this, I think, and also on the recipe website. But what you can do is, at this point, it knows what the variables are, but it doesn't know what the outcome should be. So you can do things like, is it update role? Yeah, update role. And you can say sale price will update the role of sale price, and its new role will be outcome. And so we do that. We could update the roles that way. So this is much faster than using the formula, but it doesn't give you the roles. You'd have to come back. Let me start up the new Scratch session. You'd have to come back and do something like, let's say everything else was a predictor, and it doesn't have to be. You could have any role here you want. You could have also update role, I think this will work, minus sale price, and it will select everything that's not sale price and make that a predictor. Let me just double check that this works. Yeah. So if you have like a lot of data, the only time I think the actual recipe creation will be inefficient is if you use the formula method. But again, you'd have that same problem with model.matrix. We might be able to make that a little faster because there's some Erlang-y stuff that we're doing with that formula that's not terribly, it's not inefficient, but if you have like 100,000 predictors, it's maybe not as fast as we'd like it to be. So that's, I think, one answer to your question. You mentioned, Hunter mentioned dealing with many levels and a few factors. So for dummy variables, I think we avoid maybe some of the problems that you're encountering. So again, with like model.matrix, you give it, if you gave it a formula with all those categorical predictors, it creates a model.matrix on everything. And again, the size of that can get really big. What we do under the hood of like step dummy is we create like a little model.matrix for every numeric or every categorical predictor. So we sort of use the R infrastructure in a lot of ways, but we've sort of compartmentalized how it happens compared to how model.matrix does it. So we've thought about this in a lot of ways and don't want to have, we chose to do that way to solve some problems that we thought we'd encounter, some of which are about size of the model.matrix results. So I anticipate, and you could tell us in a GitHub issue if that's not true, but I would think that you would not maybe have the same issues you would in other situations if you use a recipe. That's my hope. How would you create dummy variables for special events such as holidays, where you can get very few values of a level, for example, Christmas? We will actually talk about that specific case in part 5. So we do have something, spoiler alert, step holiday, where you give it some date field in a list of holidays. We again will show you an example, and then it will create those dummy variables for you. So for that specific instance, we have a step to do that for you. So that's not too bad. So it is sparse though, as you mentioned. Like, you know, if you're doing Christmas and you have like one year's worth of data, you know, at most you'll have a single 1 in there. That is very much related to the infrequent levels that we're talking about in this section. So we'll talk. In fact, you'll see in a few minutes whether that dummy variable comes from step holiday or step dummy or some other step. We're going to talk about ways to deal with that in just a few minutes. Yeah, so I think we'll answer your question with some stuff you're going to do in the hands-on exercise. So you're going to figure that out in just a minute. Okay, so again, we call this slide out in like one big image to say, again, with recipe, there's 3 steps. If you're like manually using a recipe, you define what you want to do, you calculate all the necessary intermediate calculations that are required for the recipe, and then these 2 functions, bake and juice, are used to actually get your process data out. So we'll look at those steps in more detail now. So we have our model recipe that we defined. When we prep it, what we do is we give it the data set that we want to use, that we want to actually do the computations on. And so you might say, well, okay, we have training equal aims train. Did we give it some data before? So if I flip back to this, you might notice we said data equal aims train. We're going to highlight this later, but you don't have to make those the same data sets. So the only thing the data does, or the recipe does with the data when you define the recipe, is it just pulls off the column names and gets their types. So you could give it like the first 3 like rows of this data, and recipe will have everything it needs to do its definitions. So for example, if aims train did not have longitude in it, it wants to know that, and it will tell you, hey, you defined some steps with some variables that were not in the data. The only other thing it wants to know about all these columns is, for example, what type are they? Are they numeric? Are they nominal? And what their roles are. So you do not have to, at this point, pass in the entire training set to the recipe function. If you don't want to do that, you don't have to. But when you go to do your calculations with prep, if you want to do something different, you can always say training equals and give it whatever data that you want to use. There's also an optional, it's usually defaulted to false, but an optional verbose mode that will give you some details as it goes. So when you run prep, what it does is it sort of goes sequentially through the recipe. Let's go back to the recipe. The first thing it does is it finds a column for step log. Now prep doesn't have to do anything here, right? It doesn't have to calculate any statistics. It doesn't have to like do anything special. But what it does after each one of these steps is, even though prep is just, its purpose is to estimate things, it immediately after each step then applies that processing to the training set. So even though step log doesn't require any statistical calculations or estimates, at the end of that step, it says, okay, now let's log the data. Because what you want is you want all subsequent steps to be able to act on the data in the format it is at that part of the recipe, right? So for example, when it gets to step other here, during prep, it calculates the frequency table of neighborhood, figures out which parts of neighborhood, if any, get lumped into other, and then at that point, after it's done its calculations, it immediately changes the factor levels of neighborhood so that it reflects what the data should be at this point in the recipe. Because what you want is you want any steps after that to have the data that will actually be that way, get the current state of the data for all the steps that came before it. So then when you run prep after this step, neighborhood has been redefined with factor levels. And then when you get to this, it will calculate, well, which one are the actual categorical columns, and then do the dummies. So any steps after, for example, if we were to add steps after step dummy and said use neighborhood, that will cause an error because neighborhood doesn't exist at this point, because we've taken that single column in the data set and made dummy variables out of it. So we would have to select variables in a different way because neighborhood is not actually in the data set after this step is executed. So it's something to think about, and I'll come back to this once or twice during the workshop. The point I want to try to make, again, in going through all that, is prep calculates everything it needs to calculate, but then at each step immediately applies that. And so you can see what it says is operation 1, step log, and it says training means it's finished, it's trained. And then it goes through and so on. One of the values of having verbose equal true here is if you have like a really expensive step you're using, you can kind of see how long it's taking to do it. And it helps sometimes to adjust expectations in terms of how you do things. Now, another thing that we'll come back to in a little bit is, unless you tell it not to at this point, what prep does is it takes that process version of the training set that it needed to do during the course of prep, and it saves it. So it sort of embeds it into the recipe object at this point. Now, if your data set is very, very large, you maybe don't want that. You don't necessarily want to carry around a terabyte of data inside your recipe. So there's an option here called retain that you can set to false, and that it won't do that. But generally speaking, when you have the space to do it, it's defaulted to true. So that value, the current state of Ames train after it's been processed through the recipe, is still contained inside of this recipe step. And that's one reason when you say verbose equal true, it will do some work to say like, hey, here's how much space in memory that data set is keeping. So if you accidentally do this on a very large data set and have verbose equal true, it will tell you that, hey, this is going to be 17 terabytes in memory, or whatever it is, which is somewhat helpful to know. So at the end of this, what do we have? We have basically a recipe object that's ready to use. And by using it, I mean, let's take the actual training set and get the process data back. We could do the same thing with our test set and so on. So now what we can do is we can apply that training to different data sets. Okay, let me check here. All right, there's no new questions. So now when we print it out after prep, you remember this said all nominal. Now it resolves the neighborhood because it's actually seen all the training data and knows what this should be. So that's another clue here, that it knows how much data there. It knows exactly what columns it should be working on. So we mentioned again back here, we want to actually apply this to the data. There's two functions, one's called bake and one's called juice. They do slightly different things. So let's talk about what the difference is between them. This is typically a stumbling point for people. We've realized that people have trouble remembering the difference between bake and juice. So let's walk through it. What juice does is, remember, we retained our training set that's been processed in this recipe by default. Remember how I said, unless you've given an option, it's going to keep that processed version of the training set in memory, basically inside the recipe. So let's say now you want to fit a model and you want to get the version of the training set that's been pushed through the recipe. You could redo all those calculations again, but as long as you have retain equal true, which is default, it's sitting right there just waiting for you to access it. So the way you get the training data back with basically no computational expense is to use this function called juice. And juice just looks up in the recipe where the processed version is and just gives it to you. It doesn't have to do any more calculations because they were done during prep. So what juice gives you is it always gives you the training set back. It can't be used for any other data besides the training set. So when you do that, you see you have the same number of data points that were in the training set, And then when you look at the columns, neighborhood is not there, but neighborhood underbar, North Ames or Edwards. So, you see the dummy variable columns here for the neighborhoods that are retained. And you can also notice down here, it didn't print it because it wasn't wide enough, but there's a neighborhood other. So you can see that we didn't go in with a factor level other, but it created one for us. And that like the Sawyer neighborhood, Gilbert, these all sort of survived that filter for othering. And the ones that did not ended up inside of this one. So at this point, we have the data that you would just then give to your model fit function, whether it's LM or parsnip or whatever, and then you can do all your modeling on the training set. There's maybe I think one other thing. Oh yeah, one thing that we sort of despise. I'll say I sort of despise about model.matrix is it takes the column names that were the factors and it sort of like smashes them together with the levels. And I always hated that because it's not very readable. And if you're making a presentation like to your boss or something on some data analysis, it's just ugly. So what StepDummy has is it has a naming function you can use to define what the new variable name should be. And its default value is to have the column name underbar, and the levels. As you can see, it's named differently than it would be named by model.matrix. And you can change that naming convention if you want, but we find this to be a lot nicer than what you would get out of like the base R methodology. So, okay, there was something in the journal channel. I'm not sure if that was an error or if that is what you expected it to be. So let me flip over to the code. So let me get that recipe. Oh, okay. So you're coming on the error message. So maybe to clarify things a little bit, if I were to prep this and say training equals Ames train, then it keeps, let me turn on verbose again, sorry. Verbose equal true. So this is exactly what we saw before. It says, this is how much it takes up in memory. You can avoid that by saying retain equal false. Let me save that. Not retained. And you see it doesn't give you that message because it didn't save it. Now, again, the problem is if you go to juice that recipe, it says, yeah, you didn't retain the data, so we can't give it back to you. So that's the message, yeah. Let me just wait. What value would be the prep step if the process model isn't retained? Oh, well, okay, so we'll talk about that in just a second. So I guess your question is like, well, what's the point if we're not going to save it? So what you could do in this particular case, on the next slide, probably we're going to talk about the bake method. And what the bake method is for, it's for any data set. So if we want to take that recipe and process the test set, we can do that. Or if we want to process the training set again, we can do that. Or if we have, some new houses, bake can be used for any data set. And so we'll talk about that in just a second. So if you don't retain it, you just lose the ability to get it back for free using juice. But you can still get the training set process value. You just have to use a different function. So let's talk about that in the notes. Okay. So as I was saying, bake works on any data set. So the difference again between juice and bake is very general. You can use it for anything. Juice is only for the training set. So if I give it new data that is a test set, you see I get all the same columns back, but it's 731 rows. It's not the training set. So again, what bake is doing is it's going through the process version of the recipe. And the first step, it says, right, log sale price, done, did that. And then it gets to the second step and says, right, step other on neighborhood, and now I know what things to put into other for the new data. So it knows how to do that and so on. So it's just applying those same process steps to this particular data set, which is the test set. And then if you're trying to do predictions, so you take the process training set, give it to the model to build your model, and then when you want to make predictions on new data, like new data for your model would be the result of bake. And that's what you would give to predict when you do this. Yeah. So hopefully that answers the question in the general channel. So again, it's been a tripping point for a long time. We're thinking about ways to maybe make this a little bit easier to remember. But right now, juice equals training set for free. Bake is for everything. So any data set that you want to use. Yeah. So if we're like beating a dead horse here, it's because like this is like the one thing in recipes I think we get the most questions on, for better or for worse. Okay. So I wanted to just recap on how data is used. So again, when you run recipe with data equals, all it does is picks off the types of data in their names. So it doesn't really need all the data to do anything when you run recipe. Prep should be the training set. It should be the data same data that's going to be given to the model. That's what it should use. And then bake is only going to get the data you want to apply those estimates from. So we might call this out later on in some of the slide notes, but it's worth maybe saying here that, and this is another common question we get is, let's say you're centering and scaling a predictor. Let's say longitude and latitude. You're going to center and scale them, which means that they have mean 0 and standard deviation 1 across all the columns. And so sometimes the question we get is, well, wait, do you recalculate the mean and standard deviation for the new data? And the answer to that for all the pre-processing methods is no. We estimate everything off of the training set. And then all the calculations, like the mean and the standard deviation, when they're applied to new data, we take the mean and standard deviation from the training set data for that column, and then use that to subtract and divide for the new data. So all of our statistics that are in the recipe, it's very, very important that they're derived only from the training set, because bad things can happen when you involve the test set or the new data in doing that. So it's a little bit conceptually, it trips people up sometime, but that is how it should be done. And as you'll see in a little bit, tidymodels and recipes in particular sort of firewalls data a little bit. So for better or for worse, what it does is it confines certain operations to only use the right data or the appropriate data, and sometimes that could be an issue. So we'll see like an example, and this gets back to the step log on the outcome. So you'll see that in a little bit. So recipes is really dogmatic about, well, tidymodels in general, I think it's pretty dogmatic about being very, what's the right word, formal about which data are given to any particular function at a particular time. Okay, so we're going to take 10 more minutes and do another hands-on. So if you go to the code file and go to line 301, you'll see the code that you can use. But here's the question is, we got rid of, we accounted for like landmark and the other very rarely occurring neighborhoods by adding them to other. Right, so let's look at another strategy that we could take, and that is just make the dummy variables as we normally would, but then let's get rid of any columns in where the training set only has a single value. So for example, if landmark is not included in the training set, then the dummy variable for that will be all 0. And so there's a step that you can look and find that will remove any columns like that. And so here's a link to the recipes reference site that has a list of all the possible steps. It's very long list. There's a lot of steps that it can be used. So I want you to maybe like Control F and search, or sort of scroll through them and see if you can find what the appropriate step would be to the recipe that would remove anything that only has one unique value. And then modify the recipe we already gave you to do what you think is the appropriate thing to account for those rarely occurring neighborhoods. So if you come out to the code file, what you'll find is around line 300 is the actual code. If you haven't been running it as you go, this is the code that you need to get to where it has all the objects you need. Here's the recipe as we had it before. Now I want you to modify this recipe as you see fit to not other things. And then instead of othering it, take away the columns that don't have any information in them, basically. So that's what we're going to do for 10 minutes. I'm going to jump off the video, and then we'll answer any technical questions that you post in Slack. And then 10 minutes, we will see what your thoughts are on how to do this.